So this next row operation is R2 plus R3, that is the new R3. So it will be 1, 3, 4, 0, 0, and then 0, 2, 4, 4, 0, and here it will be 0, 0, 0, 0. Okay, so we get all zeros in the third row, no problem. So it is in the echelon form, and then from the second equation what we get is 2x2 plus 4x3 plus 4x4 is equal to 0. So from here I think we need to take two free parameters. So we take x3 as s1, x2 as x4 as s2. Okay, so we find x2 then equal to minus 4 s1 minus 4 s2 2x2, and then that is x2 is equal to minus 2 s1 minus 2 s2. So this is the value of x2, and from the first equation x1 plus 3 x2 plus 4 x3 equal to 0. So x1 plus 3 x2, x2 was minus 2 s1 minus 2 s2 plus 4 x3, x3 was s1 equal to 0. So from here x1 minus 6 s1 plus 4 s1, that is minus 2 s1, so equal to 2 s1, and then minus 6 x s2, it becomes plus 6 s2. Therefore the solution of x is 2s1 plus 6s2 minus 2s1 minus 2s2 and s1 s2. So this solution can also be written in this form. S1, take s1 common, and then this column matrix 2 minus 2 1 0, because here it is no s1 term, and then plus s2 is equal to into 6 minus 2 0 1, 6 minus 2 0 1. So finally the null space of A is equal to span of the set of vectors 2 minus 2 1 0 comma 6 minus 2 0 1, and then the set close. Our next example is for checking the if about a vector A. Is checking for vector A 1 3 minus 1 2 4 0 and U minus 2 1 1 and a vector V 5 2. So what we need to check is so we need to check if U is in kernel of T. If U is in kernel of T. Okay. So what does it mean by kernel of T? T is, as we know, that T is the linear is the symbol for the linear transformation, which is represented by AX. Okay, which is represented by AX. So if, for example, AX is a zero null matrix, so then we will say that kernel of T that will be the kernel of T. U will be in the kernel of T. So what we need to find over here is that we need to find Tu from this transformation. So it means that we need to take we need to replace x with u, okay, and then we need to find 1 3 minus 1 2 4 0 multiplied by minus 2 1 1, and then we can see what it is. 1 minus 2 into 1 into minus 2 plus 3 into 1 and minus 1 into 1, and then what we get is 2 into minus 2 plus 4 into 1 and plus 0 into 1. So what we get over here is minus 2 plus 3 1, minus 1 is 0, and then minus 4 plus 4 is 0. So in this case we actually meet the condition for the kernel of T, because if u is in kernel of T, then T of x will be equal to 0. So our answer is yes, u is in kernel of T. Okay. The second part was that the second part was regarding V. So whether V is in range of T, whether V is in range of T. Okay, so now what is the range of T? Range of T. Range of T is to check whether T is in the range of T, we need to consider the linear system AX is equal to V. We need to consider that AX, if AX is equal to V, which means that we need to find the solution of for X. Okay, so in this case, how we find the solution? So we take A vector 1 3 minus 1 2 4 0, and then vector V will be 5 and 2. Okay, 5 and 2. So do the linear transformation. So row operation will be minus 2r1 plus r2, that will be r2. So in this case 1 3 minus 1 5, and then 2 minus 2 will be 0, 4 minus 6 is minus 2, and 0 plus 2 is 2, 2 minus 10 is minus 8. And now this is in the echelon form. So what we get is minus 2x2 plus 2x3 is equal to 8. Okay. And since x3 is now extra variable, so we can take x3 as equal to a free parameter s. So minus 2x2 plus 2s is equal to 8. So minus 2x2 is equal to minus 2s plus 8, and x2 will be equal to s minus 4. Okay, s minus 4. Yeah, so actually it was minus 8, and then it will be minus 8 here. Minus 8 and then plus 4, s plus 4. And from the first equation we get x1 plus 3 x2 minus x3 is equal to 5. So x1 plus x2 3 into s plus 4 minus x3 s. So x1 will be equal to 3s minus s 2s, it will be minus 2s, and then 12, and then 5 minus 12 is minus 7. So the solution vector is minus 2s minus 7 and s plus 4 and s. Okay, so this solution vector can also be written like this. If we take s as common, so it will be minus 2 1 1 minus 2 1 1, and then plus minus 7 4 0 minus 7 4 0 minus 7 4 0. So since we can see that this system is a consistent system, so it has a solution, a general solution. So we will see that, so therefore we will see that V is in the range of T of this transformation. So this is the answer.